Hello. So in the first video we looked at the uses of vectors, and in this video we're going to look at the absolutely essential operation of matrices. And the important bit of this is maintaining our understanding that when we write this matrix times that vector there, xy vector, it means in the top column, top row rather, 3x plus 2y, and in the lower row it means 4x plus 5y. And as long as we maintain that, everything works for us. So let's do some examples. So here is this equation that we were just looking at. Yeah, here's our simultaneous equations, and we know that we must make this left hand side here mean the left hand side of that equation. And we could do that by just thinking of the left hand side as being a vector. So if I do that, the upper component of our vector is therefore 3x plus 2y. The lower part of our vector is 4x plus 5y. So when we're interpreting this matrix multiplied by this vector, we must make it mean that. So when we look at the top row coefficients and we apply them to the xy values here, we know that we must come out with that means 3 times x plus 2 times y. So a lot of people think about that when we're in operation. I was thinking of rows and columns and how they go together. So let's have a look at the first row. So in my first row, I want to get if I look at my first column in my vector and I apply those coefficients to those xy values, then I will get my value of my resultant vector, the top one, because I started with the top row and I multiplied by my vector. So what am I going to do? I'm going to do 3x, 3 times x plus 2 times y. Yeah, 3 times x plus 2 times y, and then we add them together. So that gives me my top row, because I started with my top row of my vector. If I want the bottom row of my resultant vector on the right here, then I take my bottom row coefficients and I multiply them by my xy vector. So 4 times x, 5 times y, and I add them together. And that will give me my bottom row of my resultant vector. Okay, let's do that with some numbers in, because we're going to extend it. Now we know the idea. So if I want the top row, if I take this matrix here and I multiply it by that vector, I'm going to get, so that was a 2 by 2 matrix, isn't it? And effectively a vector here, that's a 2 rows by 1 column vector. I'm going to end up with a 2 row 1 column result. So what's going to happen here? How do I do it? Well, I'm getting my 3 by 2. I choose that first because I'm going my top row, and I'm going to apply those coefficients to the vector. So I'm going to have 3 times 7 plus 2 times 9. Yeah, 3. So let's just write that there, shall we? Out the way. Let's get that out of the way. So what have I got? I've got 3 times 7 plus 2 times 9. So 3 7s are 21. Add that. 2 times 9 is 18. The result's going to be 39. So that's what I'm going to get for my upper value. Now if I want my second row, my lower value, I'm going to take my coefficients 4 and 5 and I'm going to apply them to the values 7 and 9. So I'm going to get 4 times 7, 5 times 9, and I'm going to add them together. So 4 times 7 is 28, add them to 5 times 9 is 45, and that's going in the lower, effectively in the y value of my vector. And now I've got my two values, and I could do those operations together. Here we are. So if I take this matrix and multiply it by that vector, I'm going to get my two values coming out of those calculations, and I'm going to get the resultant vector 3973. So that's the xy value, isn't it? 39 is the x, 73 is the y. And that's all entirely consistent. That would maintain our simultaneous equation at the start. Let's have a think about how that works then if I got a matrix by a matrix. So here's the matrix we just used, and then I'm going to multiply it by a second matrix. You may note that this first column of my matrix is the values that I just used, and I've added a second column to it. So what's going to look like the result of multiplying this matrix by that matrix? Well, here I've got a 2 by 2, and there I've got 2 by 2, and in effect I'm going to get another 2 by 2. Why? Because if I multiply that column, sorry, that row by the upper row by the left-hand column, I'm going to get a value. If I take the upper row times the right-hand column, I'm going to get another value. If I take the lower row and I multiply it by the first column, I'm going to get a value. And if I take the lower row and I multiply it by the second column, I'm going to get another value. Yeah. If you think about it, what we've done is we've almost put two column vectors side by side, haven't we? So we're going to get the results of the first column vector, and then we're going to get the results of the second column vector. So a 2 by 2 multiplied by a 2 by 2 is going to give me another 2 by 2. Let's do it with the numbers just to convince ourselves that works. So first thing I'm going to do is I'm going to find the top left value of my resultant. So if I take the top column, sorry, row on the left hand matrix and I multiply those coefficients by the left hand column of the right hand matrix, yeah, so what am I going to get? That'll give me my top left, won't it? So 3 times 7 plus 2 times 9, 3 times 7 is 21, and 2 times 9 is 18. So there's our 39 value that we had before when we just looked at this vector, didn't we? And if I want to get my top right, well, I need my top row on my left hand side, and I need to multiply it by my right hand column on my second right hand vector. And if I do that, what am I going to get? 3 times 1 plus 2 times 6. Yeah, 3 times 1 is 3, plus 2 times 6 is 12. So if I add those together, I'm going to get 15 there, yeah. So I know I've got 39 in this one, I've got 15 in there. And I'm just applying the approach that we did with the ordinary vector and matrix in the first round, didn't we? Now I'm going on to the bottom ones. Well, I want to get to the bottom value. Let's just have a quick look. Is bottom left. So I take my bottom row, I multiply it by my left-hand column. And there we go. 4 times 7, 5 times 9. 4 times 7 is 28 there. 5 times 9 is 45. Add them together, and I think, what did we get before? 73, wasn't it? And then if I want to get my bottom right value, then I take my bottom row on the left and my right hand column on the right, and I'm multiplying those together. 4 times 1, 5 times 6, and I get my value here. 4 times 1 is 4, plus 5 times 6 is 30, so I'm going to get 34. So if I do all of those calculations, finalize those calculations, so that 34 is going to go there, isn't it? We had a 73, we had a 39 and a 15. So there we have it. If I multiply this matrix 2 by 2 by this matrix 2 by 2, I get these values. There we go. First matrix 2 by 2, second matrix 2 by 2, I get another 2 by 2, and I just apply those rules that we've just worked our way through. So what happens if I've got 3 by 3s? Let's build that up. Well, we need to make our fundamental maths work for our simultaneous equation, yeah? So we need to interpret for the first row, the upper row, where I take that row, the upper row, those coefficients 3, 2 and 1, and I apply them to x, y and z. I must interpret that as being 3x plus 2y plus 1z, yeah, so 3x plus 2y plus 1z, yeah, hey presto. So we're doing exactly the same thing, but now rather than multiplying two numbers together, So doing calculating just two here. I've got three items, haven't I? I've got an X, a Y, and a Z items to add together. So what I'm going to do is just try that out with the vector. I'm going to use this matrix here, and I'm going to use this rather than X, Y, and Z. I'm going to use now go straight to the vector 1, 2, 3. So what am I going to do? I'm going to multiply these out. So here I'm starting with a 3 by 3 matrix. What have I got here? I've got a 3 by 1 vector. So what am I going to get as my resultant? Well, I'm going to get another 3 by 1 vector. Why? Because when I take this first row and multiply it by that column, I get one value. When I take the middle row, multiply it by the same column, I get another value. And when I take the bottom row and I multiply them by that column, I get a third value. Yeah. So let's work that out with some numbers in. Let's have a look at the top. I want the top row of my resultant. So what do I have to do? I take my top row coefficients and on the left, and I multiply them by the column on the right. There we go. So I'm doing 3 times 1 plus 2 times 2 plus 1 times 3. Yeah. So 3 times 1 is 3. 2 times 2 is 4, and 1 times 3 is 3. I add that lot together and I'm going to have a 10 there, aren't I? If I want to do the second row, when I do the same thing, I take the second row on the left, I take the column on the right, and I multiply those values together. 4 times 1, 5 times 2, 6 times 3, there we go. And then I'm going to add them up, aren't I? So I've got a 4, sorry, I've got a 10, and I've got an 18. So what have I got here? That's 32, isn't it? And for the lower third row, the lowest row, I take the third row in the vector, so the matrix, multiply it by the column in the vector, and multiply those out. Yeah, 2 times 1 minus 10 times 2 minus 4 times 3. There we go. Add those up, and I think I get minus 32. So there we are. If I take this matrix and I multiply it by that vector, I end up with this resultant vector. Yeah, I'm just following the rules that we did for the equation, simultaneous equation. Okay, and finally, let's have a look at a matrix times matrix in a 3 by 3. Well, that's the matrix we just used. I've just created a second matrix. Yeah, and I'm just going to multiply them together. So multiply that matrix by that matrix in that order. Order is important here. So if I write Mn, I'm going to put my M matrix on the left and my N on the right. We'll have a look in another video as to why it's important. So, what the dimensions of our new resultant matrix going to be? Well, if I start with the 3 by 3 and I multiply it by a 3 by 3, I get another 3 by 3. Why? Because if I take the top row and I multiply it by the first column, I get a value. By the second column, I get another value. By the third column, I get another value. And I can do exactly the same thing with the second row of the matrix. Multiplying by the 3 values, I get three different columns, rather. I get 3 values. And finally, if I take the third or lower row and I multiply those by the column vectors, there we go, I'm going to have 3 values here, aren't I? 1 for each. So let's just work that through with our first top left. So I always start top left, and I tend to go across to the right and then down. So let me take you through that as we do it. So I'm going to start with the top left. So I'm going to start with my top row on my left-hand matrix, and I'm going to multiply it by my left-hand column of my second matrix. Yeah, 3 times 2, 2 times 7, 1 times 5. There's the calculation. That's going to give us 25, isn't it? Okay. What if I want the middle? So that gave me my top left value. I want my top middle value. So what am I going to do? If I want the top middle over here, then I have to take my top row, multiply it by my middle column. There we go. 3 times 3, 2 times 1, 1 times 2. There we go. Add those up, and I'm going to get 13 to go in there. And if I want the top right, well, of my resultant, then I need my top column and top row and my right hand column, and I do the multiplications there. 3 times 4, 2 times 2, 1 times 3. add them up, and I get 19. So I've completed the top row, and I could carry on, do exactly the same thing with the middle row and then the bottom row, and I'd end up at this final position where if I'm looking for finally for the bottom right value, then I take my bottom column on my left hand side and my right side bottom row on my left hand side and my right hand column on my right hand matrix, and I do exactly the same there. 2 times 4 minus 10 times 2 minus 4 times 3, and if I do that calculation I get minus 24. So can you see the importance of having a sequence that you go through here? So you can see I went along the top, I did left, middle and right, and then I went to the middle, and then I would go left, middle and right, and then I go to the bottom and I go left, middle and right. So I make sure that I follow a sequence. And what do I find? At the end of it, I started with a 3 by 3 matrix, I multiplied it by another 3 by 3, and I got a 3 by 3. There we go. So let's just summarize what we've learnt from that. So in principle, we're maintaining what we did for our simultaneous equation, their coefficients and values, and that allows us to multiply a matrix by a vector or a matrix by a matrix, and that works. But it is absolutely essential to get this right that we start by taking the horizontal, a row, yeah, and then we multiply, use those coefficients to multiply by a vertical or column, yeah, just like we did in the simultaneous, yeah. So if you're ever in any doubt, go back to this situation where we've got a matrix times a vector, yeah, and here I've got, if I want this top value here, I'm taking my top row, multiplying it by my vector column, 3x, 2y, 1z, and then we're adding them together. So if you're ever in any doubt, go back to that. There you go. Hope that's of use.